So now what we're going to do is we're going to draw a model for when we add integers. So the first way we model this is with a number line. So we're going to start off with something really simple and elementary, 3 plus 5. So we know that answer is 8, but here's how it looks on a number line. And so we always start at 0, and we're going to draw an arrow that reaches all the way to 3. So we modeled positive 3. Now we need to go ahead and model positive 5. And so for positive 5, we're going to start at where we left off at 3. And now we're going to count up 5 spaces. 1, 2, 3, 4, 5. And then we go ahead and draw our arrow. And it ends at 8 is our answer. So we modeled positive 5 for our second line. And then we went ahead and modeled positive 3 for our first line. And so this is the way our number line model looks if we have two positive numbers. So now we need to go ahead and model this problem. So we have 3 plus a negative 5. So just like our first one, let's go ahead and model. We're going to model positive 3. So we do our line at 0, and we count 3 spaces to the right. 1, 2, 3. So we successfully stopped at positive 3. Now we need to go ahead and model negative 5. And so we start our line at 3. Now instead of going right for a positive number, we need to go to the left, since it's negative. We need to go 5 spaces to the left. So let's go ahead and do that. 1, 2, 3, 4, 5. And we draw a line and we stop. So that line was negative 5. Our first line was positive 3. Oops. Positive 3. And we can see that our answer is where we stopped at for our second integer. So our answer where we stopped at is negative 2. And that models the first integer of 3, the second integer is negative 5, and the answer is negative 2. So now using a number line, let's go ahead and model this problem. So we have negative 3 plus a negative 5. So first off, we start at 0 on our number line. And so we're going to model negative 3 first. So negative 3, we're going to go to the left 3. So let's go and do that. 1, 2, 3. We draw our we label it. Make sure you draw our arrow just like it is in the video. So now let's go ahead and model our second number is negative 5. And so we can start right at where negative 3 is. And it's telling us we're going to the left 5. So let's go ahead and do it. 1, 2, 3, 4, 5. We draw our arrow and we stop. We're going to label that line negative 5. And our answer is where we stopped at. So where we stopped at for this one is negative 8. So we've successfully modeled negative 3 plus a negative 5 leaves us at negative 8. So now let's go ahead and model integers using yellow and red counters. And so when you get to this part of your video notes, go ahead and hold your hand up because we have little baggies made that have little red and yellow counters in them. So as we're showing stuff on the screen in the video, we're going to ask you to do that. Follow along with the counters that will be given to you. Just please be very gentle with the counters, because if you do dump those out all at once, they will start jumping all over the place, end up on the floor and somebody's hair and all kinds of stuff. So we don't want that. We want to use them for math purposes, please. My little disclaimer. And so to start here, we notice that we have two different colors. So our first color is yellow. Those are positive. You might also see it, if you see it on a worksheet that's black and white, you might also see it and it just has the letter Y written in it. So that's saying that's a yellow counter, it means it's positive. And if you see a red counter, you guessed it, those are negatives. And you might also see the letter R written in them. So it's not a pirate coin, it just means that that is for a red counter, meaning that's negative. And then you see this phrase right here, a zero pair. So all this means is that you have one positive counter, make it yellow, and you have one negative counter. So if you had one positive and one negative together, it equals 0. So the way that we can model this is kind of fun. So go ahead and model positive 3. So just go ahead and do that right now. So let's go to model positive 3. So let's take our 3 counters. Make sure your sides are yellow. And I will change them, boom, to yellow. So now let's go ahead and add 0 to that. So when we do this, we're going to create 0 pairs. So let's go ahead and add a 0 pair. So we add one yellow and one red. So we have a 0 pair here. That will equal 3. So it's pretty simple. But what happens if we added a second 0 pair? Let's go ahead and add a second 0 pair here. So we have yellow and a red. So we have our second 0 pair. So now we have 3 plus 0 plus 0 still equals 3. Nothing's changed, but we can keep adding 0 pairs. So let's go ahead and add another 0 pair. Take another yellow, make it yellow, take another red. And so what we have here is we have 3 plus 0 plus 0 plus 0 still equals 3. And so the 0 pair is gonna play a part when we add and subtract integers. So now let's go ahead and model some different addition of integers here. So we're given these two integers, a positive 3 and a positive 5. So what we do is, here, let's go ahead and pull out some 0 pairs, some not 0 pairs. We'll pull out positive 3. This is going to be our first number. And we make sure that these are yellow. Yellow, yellow, yellow. Make sure they're flipped to the yellow side. So we've successfully modeled positive 3. Let's go ahead and model positive 5 now. So let's go ahead and bring out 5 more counters. We have 5 counters there. Let's go and make sure they're flipped to the yellow side. If you're on the red, you make sure that they're on the yellow side. And so let's go ahead and label that side. So right now, this question is, do we have any 0 pairs here? The answer is no. So what we do is we go ahead and count all of the counters. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have our answer as 8. So now let's go ahead and model this problem. So we have 3 plus a negative 5. And so our first step is, let's go ahead and model our first integer, 3. So we know that's positive, so let's go ahead and let's go model 3 positives here. Make sure that they are flipped to the yellow side. So we successfully modeled positive 3. Now let's go ahead and model negative 5. So we're going to go ahead and use the red counters now. 1, 2, 3, 4, 5. And so when we figure out what this equals, we are now going to use 0 pairs. The question is, do we have any 0 pairs? Question is, yes, we do. Because what we have here, we have a yellow and a red. So that's a 0. So what we're going to do is we're going to drag those over to the side here. We don't need those anymore. So let's go find out another 0 pair. So we have a second 0 pair. We make those. We drag them to the side because that equals 0. And we have a third set of 0 pairs. So let's go ahead and take those and move them to the side. So after we're finished with our 0 pairs, the remaining counters is the answer. So we have 2 red counters. And so since they're red, that means it's negative. And so we've modeled positive 3, and we added negative 5 will give us an answer of negative 2. So now, using our yellow and red counters, let's go ahead and model when we add 2 negative numbers together. And so we're going to go ahead and model what negative 3 looks like. So let's go ahead and model negative 3. So we're going to use our red counters for this one. So let's bring 3 red counters. So we've successfully modeled negative 3. Now we're going to go ahead and add a negative 5. So let's go ahead and use some more red counters. We need 5 of these to model negative 5. So we like that. And so the question is, do we have any 0 pairs? So do we have any that we can make the combination yellow and red? The answer is no. So let's go ahead and count the counters. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 counters, but since they're red, our answer is negative. So when we added negative 3 plus negative 5 gives us an answer of negative 8.